Okay, so in this lesson, we're going to talk about how to find the domain of a rational function. So this lesson and the next lesson will discuss rational functions and how to simplify rational expressions. But the goal for this one is to find the domain of a rational function. But before we do that, let's kind of review something. We know that a rational number. Okay, so a rational number is a number that can be written so a rational number is a number that can be written as a quotient of integers. Quotient of integers. So for example, remember quotient means division. So for example, like 7 over 5 is a rational number. 7 is an integer, 5 is an integer. Negative 4 is a rational number because I can write negative 4 is negative 4 over 1. I mean, there are other ways of writing negative 4. Negative 8 over 2, things like that. All right. The negative 6 over 5 is a rational number. 4 fifths is a rational number. Those are all integers. The numerator is an integer. The denominator is an integer. Okay? So that's what a rational number is. Now let's talk about what a rational expression is. Okay, so rational expression a rational expression. So a rational number is a number that can be written as a quotient of integers. A rational expression is also a quotient. Right, it's also a quotient, Q-U-O-T-I-E-N-T. But it's a quotient. Is a quotient of polynomials. All right, so the stuff that the expressions that you had in the previous chapter are all polynomials. Okay, but by definition, a rational expression is an expression that can be written in the form P divided by Q, where P and Q are polynomials. P and Q are polynomials. All right, and then one notation is that Q cannot equal 0. All right, so Q cannot equal 0. And remember, in a rational expression, in a rational number, you can never divide by 0. So your denominator cannot be 0. That's all that's saying. Okay? All right, so here's some examples of rational expressions. Examples of rational expressions. Okay, so examples of rational expressions. A rational number is considered a rational expression. So, like negative 2/7, that's a rational expression. 4y squared over 7 is a rational expression. You have remember polynomial, remember the definition of polynomial is one or more monomials. So this is a monomial, this is a monomial. Okay? So this is a rational expression. 7q divided by q squared plus 3q minus 1. That's a rational expression. You have a polynomial divided by a polynomial. So this is a quotient of polynomials. These are all quotients of polynomials. This just happens to be a monomial. This happens to be a trinomial. Okay? We also, one more. Let's just say negative 3x squared minus 7x plus 2 divided by, let's say, 4x minus 1. All right, so this is also a rational expression. You have a trinomial. So you have a polynomial divided by polynomial. This one's a trinomial, but this one's a binomial. All right, so those are all examples of rational expressions. Okay. Now, when you take college algebra, you're going to be graphing rational functions. So let's just talk about the notation of rational functions. All right, notation of rational functions. So we know what a rational expression looks like. So a rational expression would be something like 3x minus 1 over 2x plus 5. Okay? That would be a rational expression. If I wanted to make it a rational function, I would have to use function notation. Function notation. So in other words, I'd have to say something like f of x equals this. G of x equal 3 divided by x minus 5. H of x, so remember these are just different names of functions. F of x, g of x, h of x. Since this variable is x, I'm using x here as in my notation. Let's say x minus 1 over x plus 2. So those are all examples of rational functions. So rational function is made up of rational expressions. Okay, so these are all rational expressions. It's called a rational function because of that function notation. F of x, g of x, h of x. All right, so just remember, rational function is based on that function notation. Okay, so now let's talk about we're getting to the point where we're going to talk about finding the domain of a rational function. Okay, rational function. Okay, so let's remember something about a rational number. So remember, a rational number is undefined when the denominator is 0. So a rational number is undefined when the denominator is 0. So that's something you've learned previously in a different course. So for example, 0 divided by 2 is 0. So when the numerator is 0 and the denominator is a non-zero number, then that quotient is 0. But if you have 2 divided by 0, if that denominator is 0, then we say that quotient is undefined. So you cannot divide by 0. So even if you can put this on your calculator, for example, if you say on your calculator 5 divided by 0, 5 divided by 0, let me do it again, 5 divided by 0, you get error in this calculator. All right, so that means it's undefined. So you cannot divide by 0. So when you're asked to find the domain of a rational function or a rational expression, but in particular rational function, to find the domain of a rational function or expression, because sometimes you're going to be asked to do that, rational function or expression. All right, so for example, let's suppose I had f of x equal 5 over x minus 1. All right, let's just look at that simple one. So I made this one simple. So I want to find the domain of this rational function. All right, so the domain of a rational function, the domain, just remember this, the domain is the set of x values, So right here, see this x, so the domain is set of x values. So to find the domain of a rational function, I know that that a rational function or rational expression I cannot divide by 0. Okay? My numerator can be 0. My numerator can be any number. My numerator can be any number, but my denominator cannot be 0. So what I'm asking myself is, all right, my denominator here is x minus 1. So it's this expression x minus 1. So the question is, where is that equal to 0? That's what you got to ask yourself. Now this one's simple enough to where you can say what x makes this 0. So what x makes this 0? Well, if x is 1, I get 0 because 1 minus 1 is 0. But if you can't, in many instances, you will not be able to look at this real quickly and determine that. But so what you may want to do is to determine the domain of a rational function, first take the denominator, which is x minus 1, and set it equal to 0. So you're going to solve this equation. So to get x by itself, I'm going to add 1 to both sides, combine like terms, I get x to be 1. All right. So this is what x cannot be. So what I found was that x cannot equal 1. That's what I found in this rational function. X cannot equal 1. So my domain would be any other number. Any other number I can plug in and I'll get a value back. For example, now let me do this. Remember, this is the same thing as y. So I have like the same thing as y. So if I use a t-table, just to show you, if I use a t-table, and let's say x is 0, okay, if x is 0, and I plug 0 back in, I get 5 over 0 minus 1, so that's 5 over negative 1, which is negative 5. So I get a y value back. If I plug in 4, for x, I get 5 over 4 minus 1, so that's 5 over 3, so I get 5/3. All right, so no matter what x value I choose, and you could try some more, no matter what x value I choose, I will get a value back for y. I will get a value for that expression. But if I plug in 1, if I substitute 1 into x, I get 5 divided by, all right, so 5 divided by x minus 1, I'm saying x is 1, but that's 5 over 0, and we saw earlier that we cannot divide by 0. So when x is 1, this is undefined. That's undefined. All right, so what I found, so when you find the domain of a rational function, all you have to do is take the denominator, not the numerator. The numerator doesn't matter. The numerator can be any number. It doesn't matter. It can be 0. It can be any number. But the denominator can never be 0. Your denominator can never be 0. So all you do is take the denominator and find out, well, first of all, where is it 0? And then you solve this equation. And then now you know that x cannot equal 1. All right, now here's how you're going to write this. In MyMathLab, they want you to write it like this. So the domain of f of x, is then, all right, so in MyMathLab, this is how it's going to look. It's going to say, now here's how you write the notation. See this brace? All right, so I'm going to write the words out here. So it's going to be the set of all x. Set of all x. So it look like this. Set of x. Set of all x. Such that. So the set of all x such that. The symbol for such that is this vertical line. Okay? So the symbol for such that is this. Such that x is a real number. And x, so x can be any real number. X can be any real number except x cannot equal 1, remember? So x cannot equal 1. So x is a real number, and x cannot equal 1. So just write it like this, not equal to. The symbol for not equal to is an equal sign with the slash through it. All right, now you're going to put that here. Okay, so the set of x is such that x is a real number and x cannot equal 1. And then you close the brace. So open, close. All right, so that will be what you would put on MyMathLab. So MyMathLab will look like this. Okay, so in particular, let me see if I can find one. So MyMathLab they're going to give you this right here, and you just have to fill in this number 1. But on a worksheet or a test, you're going to have to write this whole thing out. So you need to know how to write this. All right, so let's do another example, and we'll discuss this again. All right, so watch carefully for the next one. Okay, listen carefully. So this is number 2. Find the domain. Find the domain of the rational function. All right, so listen carefully. So this is number 2. Suppose that f of t. So suppose this time my variable is t. F of t is negative 4 divided by x plus 3. All right, so we'll look at it another simple one again. So some of you could probably look at this and tell me what x cannot be. You need to ask yourself that first. Okay, so let's talk about that. To find the domain of a rational expression, I need to think of what x can't be. Okay, that's what you want to think of. Think of, well, what can't x be? All right, well, to determine what x can't be, I got to think of this next. I got to think of, well, let's think of, where is my denominator 0? So let me write it a little bit better. Well, think of what x makes the denominator 0. Okay, so what x makes the denominator 0. So if I want to find out what x cannot be, what value x cannot be, I need to determine what x makes that denominator 0. Okay, so remember, in a rational function, you can never divide by 0. I don't care what the numerator is. You'll notice you're never going to even look at the numerator to determine the domain. You're just going to look at the denominator. All right. So what you're going to do is you're going to take this denominator and you're going to ask yourself, well, where's the 0? That's what this is. What x makes the denominator 0? So you solve this equation. So this is a linear equation. You just subtract 3 from both sides, and you can combine like terms. You get 0 here since they're opposites. So you get x to be negative 3. All right. So what I found that x cannot equal negative 3. That's what I found. All right. So this is my restriction. If you want to think of it that way, that's your restriction. So my restriction is that x cannot equal negative 3. Okay? So that's your restriction. So my domain will be any number. So the domain is any real number except negative 3. That's what you found. Okay? So your domain is any real number except negative 3. Now, the goal is to write it correctly. So here's how you would say this. All right, so the domain of f of t, and remember this is the variable t. Oh, I'm sorry, I messed this up, didn't I? I should have, okay. See this is t, then this should have been t. All these should have been t. So I'm just going to go ahead and change this to an x. I apologize. So that's going to be an x. All right, so these are x's. So f of x. All right, so it was easier just to change this to an x. All right, so f of x, so the domain of f of x then, is this. Remember how we said it. The set of x's such that x is any real number and x cannot equal negative 3. So that's your domain. So you stated the domain. Domain is any real number but what? negative 3. But this is how you want to write it, though. The set of x's such that x is any real number, or is a real number. It doesn't matter. Any real number, a real number, and x cannot equal negative 3. All right, so again, let's review this. To find this domain, and that's going to be important in college algebra, because in college algebra you will have to graph this, and knowing domain is going to help you to graph this in college algebra. Okay, so to find the domain, you got to look at the denominator. What values of x makes my denominator 0? So you take the denominator and you set it equal to 0 and you solve for x. And then that becomes your restriction. So I know that x cannot equal negative 3. So x can be any other number but negative 3. So any other number but negative 3. But in terms of notation, this is how you need to write it. So remember that. You need to write it like this. Okay? All right, so let's look at another one. All right, same thing, find the domain. Except for this time, I'm going to make sure I use another variable. So let's suppose I said f of t was t plus 2 divided by 3t. T plus 2 divided by 3t. All right, suppose that was my domain. I mean my function. Okay, so I want to find the domain. I want to find the domain of this rational function. Remember, this is a rational function. This is a rational function. All right, function notation. Remember that. Function notation is a rational function. So this rational function is made up of a rational expression. All right, so if I want to find the domain of this rational function, remember, all I need to do is find out what value of t makes the denominator 0. That's what I need to do. What values of t makes the denominator 0? So where is this function undefined? So basically you're asking, where is f of t undefined? That's what you're asking. So if you're asking where is the denominator 0, you're also asking where is f of t undefined. And to find out where it's undefined, remember, in a rational expression, you cannot divide by 0. So what you do is to determine what values of t makes this thing I have circled, this denominator 0, you're going to set this denominator equal to 0. And so that's what you need to find out. Where's this 3t equal to 0? Well, to get t by itself, you have this linear equation. Right now you're multiplying by 3. The opposite of multiplying by 3 is to divide by 3. And so 3 divided by 3 is 1. 1 times t is t. And 0 divided by 3 is 0. So you found what your restriction is. So my restriction is that t cannot equal 0. T cannot equal 0. So in terms of the domain, what you're saying is that I can plug in any number for t and I'll get a value back. So for example, just to show you, for example, remember this was xy, so this will be ty. So if t is let's say 4, I'm making this up, if t is 4, and I go back and wherever I see a t, I plug in 4, I'm going to get 4 plus 2, remember t plus 2, so 4 plus 2 divided by 3 times 4, remember t is 4 here, t is 4, so 3 times 4 is 12, so I get 6 over 12, so I get a half. So when t is 4, I get a y value back, I get a half. And no matter what number I plug into t, I'm going to get a value back for y. So that's the idea of a domain. So if you go back to the previous two examples, we said the domain can be any real number except in this case 0. So in other words, if I plug in negative 7, I'm making that up, negative 7, and it could be decimals. I'm using integers because they're easier to deal with, but they could be decimals, they could be fractions for t's, they could be any real number. irrational number, rational number, any real number. So if I plug in -7, notice I'm going to get -7 plus plus 2 rather, divided by 3 times -7. So that's -5 over -21. And remember, -7 plus 2 is -5. 3 times -7 is -21. And a negative divided by negative is a positive. So that's 5 over 21. So that's what this is. So the point being that no matter what I substitute for t except 0, I'm going to get a value back for y. So what I found is that the domain would be any real number, no matter what I use, any real number for x except 0. So your domain, the domain of f of t is the set of, remember how you write it, the set of t's such that t is a real number and t cannot equal 0. So that's how you write it. So my domain is an infinite set of numbers except 0. I can't use 0. It's anything else but 0. All right? Okay. Let's see. Let's try this one. All right, so let's find the domain. Find the domain. All right, suppose you want to find the domain of, let's see. All right, let's suppose we want to find the domain of, this is going to be number 4. F of x equal 3x divided by 2x plus 3. So f of x equals 3x divided by x plus 3. All right, so I'm trying to find the domain. Okay, well, again, let's go through the process. If I want to find the domain of this rational function, the function notation, this rational function, I've got to look at the denominator. That's all I got to look at is the denominator. So I need to ask myself, where is my denominator equal to 0? And so notice that this right here is a linear equation. So you subtract 3 from both sides, and I get combined like terms. I will get 2x equal -3, and to get x by itself, you divide both sides by 2, and so I get x to be -3/2. So you found your restriction. So x cannot equal -3/2. That's your restriction. Okay. So I can use any other number for x except -3/2. So the domain then, so to write the domain is the set of x's, such that x is a real number, any real number, and x cannot equal -3/2. That's your domain. Then you're done. All right, let's look at this one. Okay, number 5. Suppose we had k of x equal x plus 4 over x squared minus, let's say, 16. Oops, let me change it. X squared minus 25. Let's do that one. All right, x squared minus 25. So x plus 4 divided by x squared minus 25. All right. So again, the same thing. You want to find the domain. Find the domain. So to find the domain, remember, to find the domain of rational function, the domain will be any real number except those that make the denominator 0. So I got to find out what makes this denominator 0. Now that's where the stuff from the last chapter is going to help you in factoring. Okay, so I said this equal to 0. I said the denominator equals 0. So that's what I'm asking myself. Where is this denominator equal to 0? Okay. Well, remember when we did these, if you go back to the previous 3, when I said the denominator equals 0, this was a linear equation right here. That was a linear equation. Okay, that was a linear equation. This right here, when I said the denominator equals 0, this was a linear equation. Over here, when I set this denominator equal to 0, this was a linear equation. So here, though, and the one I'm doing right now, when I set this denominator equals 0, this is not a linear equation. Remember, this is a quadratic equation. So now we have a quadratic equation. And so what you got to do is to solve this quadratic equation, just like you did in the previous chapter, you got to factor x squared minus 25. And remember, that's the difference of two squares. So I get x minus 5 times x plus 5 equals 0. And then you said, you remember the zero factor property. That's what you got to do next, because I have two factors whose product is 0. So that means it is certain that either this one's 0 or this one is 0. And then you solve these two linear equations. So x equals 5, x equals negative 5. All right, so again, all you do is you set the denominator equals 0. Don't forget the 0, though. You got to have this. But keep in mind that this turns out to be a quadratic equation, so now you got to go back to chapter 6. Do you remember the 6.5 section? The stuff on solving quadratic equation by factoring? That's where we're at right now. And these are my restrictions. Those are my restrictions. So on, so you would say your restrictions are, there are two of them here. X cannot equal 5, cannot equal, and x cannot equal negative 5. If you want to, see those are opposites of each other, you can also say this, or you can say x cannot equal plus or minus 5. So something like that means a positive 5 or a negative 5. All right, so you can write it more compactly like this. All right, so those are restrictions. All right, so that's what x cannot be. So x can be anything else except these two numbers. So let's write the domain. So the domain is, domain of k of x is, remember we got to write in set notation now, set notation. So you say the set of x's such that, you got to write the symbol, such that x is a real number and x cannot equal plus or minus 5. All right. Now in MyMathLab, you would have to write out, or you can say x cannot equal 5, comma negative 5. All right. Okay. So that was that one. Let's do one more. Let's do one more with this. So let's say we wanted to find the domain of, let's say, this one. So let's say we had p of x equals 5 plus 7x divided by, let's say we had x cubed, all right, x cubed plus x squared minus 2x. So 5 plus 7x divided by x cubed plus x squared minus 2x. And we'll find the domain. All right, find the domain. All right, so remember, to find the domain, all you do is look to see, well, what makes the denominator 0? Because remember, we can't divide by 0. So whatever makes it 0 is going to be undefined. Makes this rational function undefined. So that's the goal. So we got to set this equation equal to 0. We need to find out where's this expression equal to 0. So set it equal to 0. All right, but notice we got to solve this equation. So you look for a GCF, previous section, solving a quadratic equation by factoring. Although this is not quadratic, you still had some problems like this cubic in there, or in a previous lesson. Okay, so if I factor out an x, I get x times x squared plus x minus 2 equals 0. All right. Now remember what we did here. You recall we took what was inside this parentheses, and I looked to see if I can factor it, or if let me do the word. Let me just take this off and just say factor. So we looked to see if this could be factored further. All right. So I said xx, because x times x is x squared. Remember, the last sign is negative. These two signs in here are different, and the larger of these will be the positive sign. And the only possibility for 2 is 2 and 1. So I'm going to put 2 here, 1 here, and it looks like this one's going to be positive, this one's going to have to be negative. All right, so the plus symbol and the subtraction symbol. But check yourself before you go on. This is negative x, this is 2x. When I add them up, I do get x, and that's what I wanted. All right, so this right here is going to go here. So I have this. I have x times x plus 2 times x minus 1 equals 0. And remember, by the zero factor property, I said each of these equals 0. So x equals 0. There's one of the solutions to this. X plus 2 equals 0, which means x equals negative 2. Here, x minus 1 equals 0, which means x equals 1. All right, now what I found, though, remember, these are solutions to this equation right here. So, but remember where that equation came from. I said that equation because I want to find out what makes this 0. Because once I find out what values of x makes this denominator 0, this becomes undefined, so which means that these are my restrictions. So my restrictions are that x cannot equal 0, x cannot equal negative 2, and x cannot equal 1. Those are restrictions. So your domain then, so you're going to write it like this, domain of p of x then is the set of x's such that x is a real number and x cannot equal, you just write this over, and x cannot equal 0, negative 2, comma 1. You can leave it like that. So x cannot equal 0, negative 2, and 1. Okay? All right, so that's going to conclude this.